All right, gang, we're going to be talking about arrays of objects. And I'm not totally sure that I've really made this clear in my prior lectures what an array actually is. I mean, you know what an array is. It's a list of values. But if I do this, int subscript I equals new int, and I say I want 4 elements in my array. And by the way, I'm just typing this in Notepad. You don't have to get this going. Then what you really have is you have a place in memory for 4 values. I forgot to give the array a name, didn't I? I'm going to call it AR. All right. Maybe AR1. We're going to have several of these. Okay, so AR1 points. It is a reference to a place in memory that can store 4 values, 4 sequential addresses in memory. So if we did this, instead of new int, what if we, place some values in it? Like that. Then these 4 values, right, would be a 3, a 4, and a 1, and a 2. Now, intuitively, we know that. We've used arrays now, we know that. But what if you declare an array of objects? Now, strings are objects. We don't think of them as that, and we just think of them as values, but they're really objects. They're, implement instantiations of a class. So I'm going to call this AR2, and I'm going to declare an array of 4 strings. So new string 4. Now what do we have? We have AR2, which is a reference to 4 spots. Those spots don't have any value in them. They're just zeros. They are null. So until we create some values and stick the references in there, like string name, oh come on, string name is equal to Bob. Now, name is a reference to some memory address that's got the value Bob in it. So somewhere out in memory, somewhere, like in that memory address, we have the string Bob. And then let's say we made up another variable, strings, whatever, address is equal to 123 South Main. So name is another reference that points to another chunk in memory. I don't know why I'm ending all of these in odd numbers when really they would be in even numbers, but okay, anyways, you get the idea. So name is now a reference to something stored in memory address that. Now, do we care where this stuff is stored? No, unlike the C++ language where you can actually get a hold of that address and you can manipulate it, we can't do that in Java. But 123 South Main, now we have 2 references. Each one of these is an object. This is a reference to the object. This is the object itself. That's why these are called reference types. String is a reference type. That's the name of that particular reference. So if you did something silly like this, address is equal to name, it doesn't copy 123 South Main into Bob. Instead, address now, oops, that was supposed to be address pointing there. Now address points to the same address that name held before, that one. So now we have 2 things that are pointing to that same memory address. Nothing is pointing to this. That's orphaned memory. The garbage collector is going to come along and delete that after a while. I'm going to get rid of that line. I want those to be 2 separate pieces of data rather than 2 references to the same piece of data. But then if we did this, AR2 subscript 0 is equal to name, AR2 subscript 1 is equal to address. Well, here's what AR2 looks like now. It's still got a sequence of memory references, but the first 2 are no longer null. The first 2 has that memory address in it. The second one has this memory address in it. Please tell me I started a recorder. Yeah, okay. And then the third and the fourth are null. So if we did a loop to print out AR2, for string S in AR2, print S like that, or print line S, it would print out, firstly, it would jump to here and print out Bob. The next element it would jump here and print out 1, 2, 3 South Main. The third one it's going to print out null, and the fourth one it's going to print out null. So that's what an array of reference type is. An array of objects. It doesn't contain the objects themselves, it contains references to them. It contains the address where the object is really stored. Hope that kind of makes sense, because now we're going to actually play with that concept again. I don't think I've done a homework assignment based on arrays of triangles, so we're going to do an array of triangles. We need a class called triangle. If I was a good programmer, I would put the class in its own file. I'm not calling this public because each Java file can only contain one public class, and it has to be the one that the file is named after. Okay, and a triangle has several values. It's only got two, really. Int, base, height. This is going to be a very lame class. I'm not putting in the getters and the setters. If I tell you to do that, I want you to do that, but this is a short lecture, so I'm not going to put that in there. All right, now we're going to create some triangles. Why don't we put a setter in there, though? So void set int base, comma, int height, but I'm only going to create one setter for both of them rather than putting two mutators. So void set, parentheses, int base, comma, int height, in parentheses. This dot base equals base, semicolon. This dot height equals height, semicolon. Now I have a setter for both of them. That really should be a constructor, but I'm going to leave it as is. So I'm going to come down here. I'm going to create a triangle. Triangle Fred is equal to new triangle. And in Fred.set, he's got a base of 10 and a height of 10. Now I'm going to create another triangle. Triangle Barney is equal to new triangle. Barney's got different. Barney's a little bit shorter. Barney.set. He's got a base of 10. He's just as wide as Fred, but he's only half as tall. There we go. Now we can create an array that'll store those values. How long do I want this thing to be? I don't know. If I just wanted to contain those values, I could do something like this. Triangle TA for triangle array, except I need to put these square brackets here to indicate that it's an array, is equal to, and I'm going to put curly braces, and I'm going to put Fred, comma, Barney inside the curly braces. I'm using an initializer list. Now I'm never going to really do that. This is just the first example. I created two triangles and then I stored their addresses, their references, into an array. And since I use an initializer list, the array is going to be of the exact length to hold those two things. No more, no less. It's always going to be 2. There's no way to add to it, unlike Python, where you can add things to a list and it'll grow and shrink as necessary. All right, then after that, let's do it the real way you would do it, which is to create an array. Let's say we want 4 triangles in our array. So triangle, well, we've already got an array. Why don't we print that array out with just a for each loop? So for, parentheses, triangle T, colon, TA, for every triangle in TA, system.out.println T. That's just going to print garbage because we don't have a toString method for our triangle. We should add a toString method to our triangle to make this work, because when we run it, all it's going to print in is those memory addresses. Actually a hashed version of them, but see, here we go. That's what it printed out, and that's what it printed out. That's no good to us. We actually want to see the data. Why don't I use printf instead rather than go add a toString? I'm being totally lazy. Printf, parentheses, quote, base, colon, %d, space, height, colon, %d, and I need to kind of go to the next line, so I'm not going to try to squeeze all this onto the for loop line, which was lame anyways. So printf, parentheses quote, base, colon, %d, height, colon, %d, and then a \n to make sure it goes to the next line, comma, t dot base, comma, t dot height, end parentheses and semicolon. Now we'll get some good data, right? It's just not gonna, it's not gonna just print out the references. It's actually gonna print out some good data.
So how come sometimes on the printf it won't take a comma? Sometimes I have to do a plus. Is there a reason for that? Like sometimes if I do a comma, it just gives me a red line.
Well, if you, the question is when we do printf, why are we using commas? Sometimes we have to use pluses to get it to work. That's not. You're going to use commas to fill in the placeholders. And by the way, close your ears and go la 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 if you're not a Python programmer, but if you're taking Python, then the print statement's going to look like this. There's going to be a % there, and then you're going to put the parameters inside parentheses like that. That's how you would do the printf in Python, except you just change it to print. But all of the parameters need to be separated by commas, the things that fill in the placeholders. Now, if you're just printing things out,
Yeah, that makes sense.
if you're printing things out like a normal print statement, system.out.println, height equals plus Fred.base, base equals Fred.base, right? Fred base equals that. I'm going to delete that line. But we had to use a plus sign here because we're not filling in parameters.
Okay.
This is a function call, and the various parts of a function call have to be separated by parameters.
Okay.
When we call Fred.base, it's calling a ToString method to convert it to a string to append it to that string for output, which again you can't do in Java. If you wanted to do it in Java and everybody else ignored this, you could do that. But normally in Java we just separate everything by in Python, right. That's how you would do it in Python. You would use a plus sign, but you'd have to convert it to a string. Or you could separate everything with commas. You can't separate everything with commas in this language unless they're parameters to a printf.
Okay. Yeah, that makes sense. Okay.
All right, so that's the correct syntax for that. Now I'm going to delete that line. And I'm going to run it because I want to see our base and height show up in our output. Yep, it worked. It printed out 2 objects. Now, are you gonna have your objects created in advance so that you can build your array with an initializer list? No, you're not going to be able to do that. So we're going to reallocate this array, but we're going to make it 4 long. And then we're going to put our own data in. Maybe we'll only make it even 3 long. This is going to be a short example, right? We don't need 1,000,000 elements in it. But, so TA is equal to new triangle, square braces, and I want it to be 3 long, in square, semicolon. Now I have 3 triangles, but if I print them out, they're just going to be nulls. If I copied and pasted this line here, it would crash. I'm obviously going to delete it because I just said it's going to crash. But if I copy and paste that, it's going to crash. Because we don't have any objects to point to. So when it calculates t as part of this for each loop, it's trying to do what's known as dereferencing. It's trying to print out the base of the object stored at memory address 0. Well, there is no object at null. Anytime you have null, you can't print out the members of it. You can't call methods on it. You can't access the variables that are attached to it. So that's not going to work. I'm going to delete that, and I'm going to type in something that's going to print out the memory addresses like our original one was. For parentheses, triangle T colon and TA, for triangle T colon TA, system.out.println parentheses T. So just print the elements. Now, do we have to go so fancy if it's just an array of ints? No, we're talking about arrays of objects now, not primitive data types. This would work fine if it was an array of ints or floats or whatever it was, but this isn't a primitive data type. It's an object type. It's a class. So now when it runs, we're going to see it print out 4 nulls in a row. 3, well, I made it 3 length, 3 nulls in a row. And if you tried to access .base or .height or call any methods on null, it would crash just like we saw. So that's not too cool. We need to fill it in with data. Why don't we use a for loop that counts 3 objects, creates 3 objects, and stores them in the array? I'm not digging this because it was just printing out null, so I'm going to delete that. But I'm going to make a for loop, but it's going to be an index-based loop for I equals 0, I is less than 3, except actually where it asks for the length of the array. You can't use a for each loop to fill in a new array, to allocate new objects. For each is basically for doing read-only. Treat for each as though those variables were read-only. You can't change them. Some languages you can, not this one. So we're going to use a index counter, so I'm going to call it I. For parentheses int I equals 0, that's our starting point. Semicolon. I could do I less than 3, but that's kind of lame. Instead, I'm going to ask the array for its length. So I less than ta dot length, semicolon. Now this is just a property, it's not a method call, so we don't put parentheses, unlike if we're calculating the length of the string, in which case you do put the parentheses there. And then I plus plus. And now we need to put some data in. I'm going to be incredibly lame and not even ask for input or use a random number generator to get the next values. All I'm going to do is this. TA subscript I is equal to new triangle. And then I'm going to set the values of that triangle. TA subscript I dot set equal, 10 comma 10. Every triangle is going to be 10 comma 10. And then I goofed it. It didn't work. Do you spot what I did wrong? The error is on this line, actually. When I call new, what do I have to do? You can see in my call to Fred and Barney up here.
Parentheses?
Yep, I need the parentheses. You can't call a method, even a constructor, without parentheses. Okay. I regret setting it up this way, so I'm going to modify it just a little bit. Forgive me for this. I'm going to delete all that. Sorry. Triangle T equals new triangle, parentheses in parentheses. T dot set, and I need to set 2 values. I could just set them both equal to I, right? Because I is going to count 0, 1, and 2. I comma I. Doesn't make much sense to have something with a height of 0 and a base of 0, but it could happen. And then I'm going to set that element equal to that reference. So it's going to be TA subscript I equals T. TA subscript I, TA square brace I, n square equals T. So you see what we did here? Here we created a reference to the object. And here we set that element of the array based on its index value, 0 to begin with, equal to that pointer. And then the next time we iterate through the loop, it's going to create a brand new object at a different memory address and set its values. And then TA subscript 1 is going to equal that. Then it's going to do it one more time. Now let's print those values out. We could do it just like this. We could copy and paste this code. Or we could do an index-based loop. Well, me being lazy, the first time I do it, I'm just going to copy and paste that print loop. This is the one that does for each triangle T and TA, print F, base and height, right? That's the one I want.
Basically, you're saying that now the array name is T.
Nope, the array name is still TA. It's just that we have a reference to it for every triangle in TA. And oh, by the way, call those references T. We could have called them anything. We could have called them Wilma, as long as we put Wilma here and Wilma here. It's still the same array.
You want to leave Wilma in the for loop? The TA?
It is in the for loop, right there.
The one above it? I guess, okay, it's a different for loop. Okay.
Right. This is a different for loop, and it's accessing it by array name rather than by temporary variable name, which is what you get when you use a for each loop. And I know it's a little bit confusing toggling between index-based loops and for-each loops. The book has a different name for for-each loops. They call it something slightly different. I wish I remembered. I'm going to take note that this is a for-each loop, and that this is an index-based for loop. And as a matter of fact, we're going to print it out using a for-each loop as well. Excuse me, an index-based loop. We're going to do it both ways. So once you get this code working, and I guess I better run it. I haven't run it recently. We have 3 triangles. The first one, height 0, base 0, height 1, base 1, height 2, base 2. We could have made a lot more triangles by putting 10 there. Right? And so on. I'm going to change that back to 3 just because that's what it was a minute ago. All right, this is printing it out with a for each loop. I'm going to go ahead and put curly braces there because that's what we normally like to see. Now we're going to do it with an index-based loop, so we need a counter for int I equals 0. I is less than the length of the array, which is ta.length, semicolon, I plus plus, system, that is going to be almost the same. I could probably copy and paste it better. System.out.printf, parentheses, quote. I'm going to copy it. Copy, paste, but we're going to have to change that t.base and that t.height to be the name of the array followed by the index. So since this is underlined, I'm going to change that to ta subscript I, because that's that element in the array, and then ta subscript I there. So the first time it iterates through, it's going to be ta subscript 0. We're printing out the first element, then it's going to run through, and I is going to equal 1, so ta subscript 1 is the second element. And then one more time to the loop, I is going to be 2, so it's going to print out ta subscript 2, which is the third element. So take a good look at the difference between the index-based for loop and the for each loop. I don't care which one you use on the exams, I don't believe. I think on the exam I say print it out with a loop. I don't care which one you use. And by the way, these syntaxes are remarkably similar to how you would do it in Python. And I'm only mentioning Python, but I know that several of y'all are taking the Python course, concurrently with this one. Except, of course, the print statement's format is different. It's just print. And the for loop syntax is considerably different. But you can still use a for each loop, which almost looks the same, except it's got the word I in there. Or you could do it like that. Just make sure I haven't broke it. Compile it again. Okay, so what would be the cool way of doing it? We shouldn't just fill in the triangle automatically like that. We should ask for the values, right? We should ask for the base and the height of the values. And what if we wanted to print the areas, right? We don't have any way of calculating the area. We could, but let's go add a print area method to our triangle class. We have a set, but let's do, since these are we're going to have to make this return as a double, even though these are ints. And as a matter of fact, we should replace all the occurrences of ints with double. But the reason I'm saying that is because the formula for a triangle is base times height divided by 2, and that divided by 2 means that it's going to have to return a double. And why limit ourselves to ints anyways? Now I've got an error with those printf statements. I'm deeply regretting making that change. I would have to change those printf statements to be %f rather than %d. I should have planned ahead. We better fix that now before we go any further. I'm just going to do a Control F if you're using this editor. If you're using TextEdit, it's a different one. And look for printf. And where it says %D, it better say %F, because now these are floating point types. There's another one down here similarly. %D, change those to %F, %F. And since I did some radical revisionism, I better run it. Make sure I didn't break it. And what do you know I did?
Why am I working?
Yeah, I'll come over there and check it out in just a sec. Oh, I had one more %D here. %F, %F. There were 3 places, 3 lines that needed fixing. This first loop, right under where we created Fred and Barney. And then later on, in our first for each loop that I denoted as such. And then in the for index-based loop. All right, hope I didn't break y'all's code too much. I'm going to start at the top and then scroll down. You can eyeball it. Pause it as need. There's the triangle class. Here's the main method up until the index-based for loop. Pause it as you need. Here's where we print the index-based for loop for printing it out. Nope, this is where we create the triangles. See, I should put that in a comment. Create the triangles and place their references into the array. And then down here for each loop to print. Index-based for loop to print. And that should be it. You can check them. Scroll back, rewind the video. I hope we have it working. Well, I haven't tested it again, have I? I'm talking big. I better back that up with words. There we go. But we're not printing out the area. We could calculate the area right here, right? I could do this. Don't do this because I'm going to undo it. Double area is equal to TA subscript I dot base times TA subscript, yeah, right. I could do this. Right. But I'm not gonna. I'm gonna make a method that calculates it. That's the wrong formula anyways. I forgot to divide it by 0.5 after I did it. Delete that line, come up here. Yeah, I deleted that line entirely. I'm going to scroll up here and I'm going to create a GetArea method. But I'm going to take a pause first. Alright. I should have put triangle in its own class. So I should have done, file new, create a triangle, put that there. If you did like me and you put it in the same class, make sure it's above the other class. Public class Java application 3. Alright, let's write a GetArea method. I want it public. I should have made this one public too. Public void set, like that. And then public void set, no, GetArea. And it's not a void because it's returning something. Public double GetArea, parentheses in parentheses. Let's calculate the area and return it. I'm going to tell you what not to do. Don't do this. Don't come up here and put a variable to hold that value and then calculate it and return it. Whenever you have a calculated variable, don't declare it as a member of the class. Instead, make it a local variable. So double float equals this dot base times this dot height divided by 2.0, or just divided by 2 would work. But if these were ints, we would want to make it 2.0. Well, what do you know? I'm getting an error. Because I gave it a stupid name. Why did I call it double float? Double area equals this dot base times this dot height.
When you return?
Now we need to return, exactly. Return area. And if you are doing NetBeans, the last thing I'm going to do is I'm going to highlight those two variables and I'm going to do encapsulate to make getters and setters. But I'm not going to do that yet because it'll change the way the code looks. So that's our GetArea method. I hope it works. I guess I can compile and run it. We haven't changed the behavior of the code, but we added a new method. I want to make sure I don't have any syntax errors in it. Apparently I don't. All right, we're going to do some cleanup of it. Did you see our output? It looks nasty now. What do I mean by that? It's got 1,000,000 decimal points. I don't like seeing all those places. Okay, when I say 1,000,000, that's a slight exaggeration. It's got 6. So these base %fs, make them base, how many decimal places do we want? 2? Make that, instead of %f, make it %.2f, only 2 places. And height, instead of %f, make it %.2f. And find the other 2 lines that use those percents as well, and make that change. %.2f, %.2f. If you forget the percent, it doesn't do what we, excuse me, if you forget the dot, it doesn't do what we want. And then, well, lastly, %.2f, %.2f. All right, I'm happy. Looks a lot better. But we're not printing out the area. That's going to make our printf statement look more complicated. It's going to have 3 placeholders rather than 2. Well, we just have to grit our teeth and do it. So, before the /n, we're going to have one more placeholder. And this is on the for each loop, right? The first one of the 2 that we use to print out the array. So here, before the the /n, do area, colon, and again, we can do %.2f. But now we have a new parameter, a new placeholder we need to fill in with a parameter. So over here, and I'm going to make a deliberate mistake so I can ask my viewers here what I did wrong. T.GetArea. All right. Why is it underlining GetArea? Because base and height are member variables. They're instance variables. But area is a method, yeah. Okay. Then you'd want to make the same change down here. In front of the %n, I keep calling it a percent. In front of the /n, the new line, area, colon, %.2f. And then since this is getting really long, I'm going to add a character term there. You don't need to do that, but you do need to add the parameter to fill in that placeholder, TA subscript I dot get area, parentheses and parentheses. And I forgot my comma. Now I could add a ToString method. That would make it easy to print these things. I guess I will add a ToString method and then we'll call this lecture done. So I'm going to scroll up here. What does ToString do? All it does is it constructs a string like that and returns it. So, find my triangle class. It needs to return a string, so public string, capital S, ToString, capital S, parentheses in parentheses, curly brace. We need to construct our string and then return it. So capital S string space S equals string.format, and it's going to look a lot like that other one did. In fact, I could probably go and copy and paste it. I'm going to make this a capital B to distinguish it because we were using lowercase b's in the rest of our print statements. Base colon %.2f space height colon %.2f space area colon percent dot 2f, but then we have to fill in those placeholders. So after our end quote, before our parentheses, comma, this dot base, comma, this dot height, comma, and this dot get area, parentheses in parentheses. And then one more closing parentheses and a semicolon. Then we better return that. That's going to be the next line, return S. Now again, that didn't change anything because we haven't called that method anywhere. But we will. Make sure it's still working. I don't want any syntax errors. Still working. Notice the first time it's not printing out the area, but that's because I didn't modify that first loop to call GetArea, and I did the second one. One more loop, but this time we're going to use ToString, and it's going to look a lot simpler. Scrolling down here, scrolling down here, scrolling down here, finding the last loop. All right, I'm going to make it a for each loop because that's the simplest syntax. For each loop using ToString. So for parentheses, triangle T, colon, TA, close parentheses, curly brace, system.out.println, parentheses, T.get string, parentheses in parentheses. And that's, excuse me, it's ToString. T.toString. Parentheses in parentheses. Now that'll work. If I run it, my last output's going to print something with capital B's, because if you remember, I made my ToString return something with capital B's and A's, all the initial caps. But we're going to make one more change after this, because you don't actually have to put the call to ToString. It will get called automatically. Okay, so here's that last loop. Print it out that fast. This code is a lot cleaner than this code and this code, because we did the heavy lifting inside ToString. But if we delete the reference to the ToString method, if I come over here and I take out the dot ToString parentheses in parentheses, it works just as well, because printf is accepting a string, and if we pass it something else other than a string, it'll call the ToString method on it automatically. There, now that's the most beautiful thing we could come up with. I like that. Last change, go back up to triangle, and if you're using NetBeans, highlight the member variables and do encapsulate using a refactor menu. Double base height. You can right click and find refactor there, or you can click refactor from the main menu up here. Encapsulate fields. It asks us which fields we want to encapsulate. They're all good. And there we go. It puts them up at the top of the class, which I don't like. So I'm going to cut all of this stuff, this get base and set base and get height and set height, and cut it and move it to the bottom of the triangle class. Right click cut. And I'm going to put it at the very end before the closing brace for the class. And I could go on and I could make all sorts of changes. I don't particularly like seeing these Java doc comments. I could do delete, return the base, delete, set the base, delete, return the height. And honestly, I like even putting all of this code, although it's poor programming practice, on one line like this, because they're just getters and setters, right? You don't have to do all this, especially if you're not using NetBeans. But if I ask you to encapsulate your variables, if I ask you to provide mutators and accessors, get them set, then you got to do it for the grade. But that's not the most important part of the lecture, so that's why I waited to do it until the end. All right, let's scroll up and look at the whole class again, and then we will call the lecture done. Then our getters and setters. And this is the end of the class, and so I like marking it as thus, end triangle class. All right, that makes sense?
Yeah.
Okay, cool.
I like putting in methods. It seems like it's almost easier,
Yeah,
almost more structured.
exactly, right. And if we go back down here, if you remember where we were printing things out with the percent signs, it's kind of made it harder to follow because we have to call getBase and getHide. But
You know, I never realized the get, you had to put the parentheses, you know, never put two and two together.
right, yeah. All right, why don't we stop here?